Hello everyone, welcome to this session. In this session, we will learn about the precision and recall. So let's start with the precision matrix. Okay, so here is a confusion matrix of the medical model. So in this model, we want to avoid this false negative case. That is, we want to avoid any such kind of mistake that consider the sick patient as a healthy, as it could be the worst case. So in this case, precision matrix can be the good to check if the model is good or not. So precision can be defined as out of all the patients predicted to be positive, how many are actually positive. In other words, you can say that out of all patients we diagnosed with an illness, how many did we classify correctly? So precision is this column because this column is a sick patient that we predicted or diagnosed as a sick. So this 1000 is the correct one. So precision would be 1000 divided by 1800, which is total number of the patient diagnosis as a sick, and that is equal to 55.6%. Okay, so this is not a high number because this is not a precise model, but this is okay because we are avoiding this false negative case. Okay, now look at this spam detector model. Okay, so here we want to calculate the precision for this model, and we want to compare it with the previous model. So we know that in this model, precision is important, as I have explained in the previous session that in this model we want to avoid this false positive case. So this false positive case is in this column, which we want to avoid. So precision says that out of all the emails sent to the spam folder, how many were actually spam. So here we have 100 which are correct, and precision will be 100 divided by 130, which is all the one that we have sent to the spam folder, and that is 76.9%, which is higher. Okay, this is better because this model needs a high precision. Okay, so now look at the second matrix, which is recall. Okay, so here again we will take the medical model, and recall is defined as out of all the points that are labeled positive, how many of them are correctly predicted as positive. So in this model, recall can be defined as out of all the sick patient. Okay, out of all the sick patient, how many did we correctly diagnose as a sick? Okay, so answer can be calculated by this row. Okay, this row catches the worst case, that is a false negative case. So we can see that the recall is important in the medical model, and recall recall sorry can be calculated by calculated by 1200. We can calculate out of the 1200, 1000 of them we correctly diagnosed this correctly. Okay, so recall will be 1000 divided by 1200, which is 83.3%. Okay, so actually I have not mentioned this recall statement in this PPT, so sorry for that. So the previous model, this model has a higher recall, that is 83.3%. Okay, so now we will look at the email model. Okay, so here recall is calculated simply out of all the spam emails. Okay, out of all the spam emails, how many were correctly sent to the spam folder? So an answer will for this will be in this row. Okay, so we have 100 correctly sent to the spam folder, that is divided by the total number of spam email, that is 270. So that is equal to 37%. So but here we want to avoid this false positive case, so it is okay if it has a low recall. Okay, so to summarize, the precise and recall matrix is used to evaluate the model depending upon the scenario that we want to handle. Okay, so in the medical model, to avoid this false negative case, we need to use a recall matrix, for which we will consider this row, that will calculate the number of sick patient out of all the predicted sick patient. Okay. So in the spam detector model, to avoid this false positive case, we need to use the precision matrix. Okay, for which we use this column. Out of all the emails sent to the spam folder, number of actual spam emails. Okay, so as of for now, we have learned the recall and precision. Okay. Okay, so medical model has a precision of 55.7% and recall of 83.3% and supposed to be higher recall model. Okay, and spam detector model has a precision of 76.9% and recall of 37%. That is supposed to be a higher precision model. So let's think that do we need to carry this two number, that is precision and recall, all the time to evaluate the model? This is inconvenient. It is better to have only one score to evaluate the model. So how do we combine these two scores into one? A simple way is to just take the average of two. So the average of the medical model is 69.5% and for the email model average is 56.95%. So you might be thinking that this is not different from the accuracy. This average is not different from the accuracy. In order to see whether it is a better metric or not, try it with the credit card fraud example. Okay. So this is the credit card fraud example. Okay. Let's take this model which is unpleasant, saying that all the transactions are good. Okay. So here I have created this confusion matrix. In okay, here what I'm saying, like this fraud transaction, that actually how many actual fraud transaction are there, and with that how many predicted, how many we have predicted this for this fraud transaction. Actually they have this 400 transaction, and out of this how many we have predicted as fraud transaction? It is zero. None of them we have calculated as we have predicted as a fraud transaction, so it is zero here. Okay, out of the actual fraud transaction, okay, out of this how many we have predicted as good transaction? Obviously we have predicted as good one, so this is 400 here. Okay, so here in this, out of actual good transaction, which is this one, okay, out of which how many we have predicted as a fraud transaction? Actually we have predicted as all good transactions, so it will be zero here. And then out of actual good transaction, how many of them we have predicted as good transaction? Obviously we, this is good transaction. Out of actual we have predicted as all good, so this is 4 lakh. Okay, so now in order to calculate the precision, we will use this column. Okay, this says that how many we predicted fraud transaction correctly out of the all predicted fraud transaction. So here it is 0 by 0, which is undefined, and this is 100%, since we have made zero mistake among the ones who predicted the positive, or which is what precision tries to measure. Okay, okay. So recall, how to point a recall? Recall is how many fraudulent we 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 want to, sorry, this is a, in this by this column we will find the recall. So recall is how many fraudulent we catch out of all the fraud transaction. So that is 0 by 400, that is equal to the 0. So if we calculate the average of both, it is 50%, which is a higher number for such a bad model which does not catch any of the fraud transaction. And I want to give the low score for such a model. So average is not good, that good. Okay, let's take the opposite model for this. Okay, so here the model says that all the transactions are bad in order to catch the fraud transaction. Okay, so here we have created this confusion matrix. You can better understand this confusion matrix now. Okay, out of all the fraud transaction, actually fraud transaction, how many we have predicted as fraud transactions? So this say there are 400. Okay, and out of all the fraud transactions, how many we have predicted good? And none of them have predicted as good, so it is 0 here. Out of good transactions, how many we have predicted as bad or fraud? So it is 4 lakh. And out of all the good transactions, how many we have predicted as good transactions? None of them have predicted, so it is 0 here. Okay, so So here this is the confusion matrix which we have created here. So we need to calculate the precision here, and when we calculate the precision, it will be this 400 by total this. So that is equal to 0.09%, and recall will be calculated by the zero. So it is 400 divided by 400, that is 1, that is 100%. Okay. Now if we calculate the average, that will be equal to the 50%. Again we get the high score for such a bad model, as this model makes a good transition, also a bad one. So we want to get this low score somewhere close to the zero. Okay. So in summary, average is not a great thing if either the precision or recall is very low. So we want the number to be low even if other one is high. Okay. So here is a solution. There is another type of average called the harmonic mean. Okay. Let's say we have the two number x and y, which x is lower than the y, and average is defined as a x plus y by 2, and harmonic mean is defined as a 2xy by x plus y. Okay. It always lies between this x and y, and it is fact that the harmonic mean is less than, always less than this arithmetic mean. Okay. So this harmonic mean is always closer to the number, smaller number than the higher number. Okay, let's take an example. So here precision is equal to 1, recall is equal to 0, and when we calculate the average is 0.5, and when we put this two value to this harmonic mean value function, so it will get the harmonic mean equal to 0. Now take another example where precision equal to 0.2, recall equal to 0.8. So average is 0.5 and harmonic mean is 0.32. That means it is, harmonic mean is closer to the smaller one. Here also it is closer to the smaller one. Okay. So we will be using the harmonic mean, which is also known as the F1 score, and it is close to the one which is smaller. Okay. Now if we calculate the F1 score for the credit card, for example, then we get the F1 score as equal to 0. Okay. So you have learned about this precision, recall, and F1 score in this session. So I will see you in the next section. Thanks for watching this video.